Okay, let's look at example 2, where we're graphing f of x equals x squared plus 2. First thing to do is identify the basic shape. Well, this is an x squared, which was that parabola, so that u. And again, I know that my key points go in the same y direction. Then I'm asked to find the vertical shift. Well, the vertical shift is the number that I'm adding to the function. Well, look here. Am I adding or subtracting something to this function? I am. I'm adding 2. That means that 2 is positive, which will mean I'm going to go up 2. Then I try to figure out, do I have a horizontal shift? Is there something here that I'm adding or subtracting to x that's being squared? Is there something in parentheses, under the radical, in the absolute value bars, etc.? Nope. So I don't have a horizontal shift. I'm going to write 0. Then I know I can get my vertex from these values, and the vertex has an x value of whatever the horizontal shift was, happens to be 0, and a y value of whatever my vertical shift was. Well, if I'm going up 2, again, that's a positive 2, so that would be 2. So here, my x-axis, my y-axis. Again, I'm going to change the scale again. So here's 1, 2, 3. And I'm going to plot my point of 0, 2. So there is the new vertex for my graph. Then I need to look at the compression stretch, the number I'm multiplying to the function. Well, am I multiplying something out there? No, I'm not. So I can always write 1 because you can always multiply a function by 1. Then I have to use this number to find my key points. Remember, your key points for your square are in the same direction, in the same y direction. And since this is a positive one, this means I need to go up 1 unit. So from the vertex, I go up 1 unit and then left 1, up 1 unit, and then right 1. And again, it's left and right because the key points for my function of x squared have key points that go left and right. Last thing I need to do is find the x-intercepts. So I set the function x squared plus 2 equal to 0, and I solve it for x. Now, in order to solve this by extraction of roots, I need to isolate the x squared. So if I subtract 2 from both sides, I get that x squared is equal to negative 2. Taking the square root of both sides, I get that x is equal to plus or minus I root 2. But this here has an I in it, which makes it an imaginary number. Is there any place on the graph where I can graph something that's imaginary? No, I can't, right? There's no place here where I can graph an imaginary number. So because this is imaginary, I do not have x-intercepts. Because my answer is imaginary, I do not have x-intercepts. So let's go ahead and connect the dots. Again, make sure that you keep the same shape as your basic function. And we did. And if you notice here, here's my x-axis. I'm pointed up. Will I ever cross this? No. It makes absolute sense that I would write none for my x-intercepts. Let's go to the next one. Same thing. First, identify your basic shape. Well, if I take a look here, I have 2 times x plus 2 squared. An x squared is a square function, and that we know is a u. And again, we know that it has key points both in the same y direction, but one to the left and one to the right. Then I have to ask myself, do I have a vertical shift? Is there a number that's being added to the function? There is a plus 2. So that means I'm going to be going up 2 units. Is there a number that I'm adding or subtracting to x? So is there a number that's in parentheses here with x? There is. There's a plus 2. So remember, these are always opposite the sign, so a plus 2 would actually move us left 2 units. So let's find the new vertex. Remember, the vertex is made up of the horizontal shift and the vertical shift. So the horizontal shift is left 2, again opposite this number, so the opposite of a positive 2 would move us negative 2 units. My vertical shift is up 2, so that's going to be a positive 2. So now my vertex is negative 2, comma 2. I'm going to go to negative 2, positive 2. Here's my vertex. Then I have to figure out, do I have a compression stretch? Is there a number that I'm multiplying the function by? Well, there is. I have a 2 out here. I'm multiplying the x's by 2, so that means that I have a compression stretch of 2. Well, this means that I'm going to, because 2 is positive, I'm going to be going up 2 units. And then whatever direction my key points go. Well, remember that's going to be up 2 units into the left and up 2 units into the right from the vertex. So again, here's my vertex, the vertex I found to be at negative 2, 2. From here I go up 2 units and then 1 to the left. Back to my vertex, I go up 2 units and 1 to the right. Notice you always go over 1. You never go over anything other than 1. Also, just note that you can only use the compression stretch to find your key points. You can't continue to use it. It doesn't work like slope. So the only points that you can find using your compression stretch are those key points. Please be really careful with that. You cannot use it like slope. You can just use it for those first key points and then that's it. Then I'm asked to find the x-intercept. Same thing I did before. I set the function to times x plus 2 squared plus 2 equal to 0 and I solve it for x. So subtract 2 from both sides. Divide both sides by a 2. Take the square root of both sides to solve and I get that x plus 2 is equal to plus or minus, well the square root of negative 1 is I. Solving for x I get that x is equal to negative 2 plus or minus I. Can I graph an imaginary number? No, there's no way that I can graph an imaginary number, so I say that I have none in terms of x-intercepts. I don't have x-intercepts. Lastly, connect your dots. Make sure you have the same shape as your original basic shape, and we do. And then notice that having a compression stretch of 2 actually made us a little thinner and taller. Right? So compression stretches will, when you have them, change the look a little bit of that graph. It'll stretch it vertically or shrink it vertically. Next example, I have negative 2 times x minus 1 squared minus 3. Again, same thing, figure out your basic shape. Well, I have an x squared, which is a parabola. And I remember that my parabola has key points in the same y direction. Vertical shift. Do I have a vertical shift? Is there a number I'm adding or subtracting to the function? Yep, I have a minus 3. Well, a minus means I'm going to go down 3 units. Do I have a horizontal shift? Is there a number in parentheses with x? There sure is. It's a minus 1. Remember, those are going to be opposite that, so a minus would actually move me right 1 unit. So the vertex having that kind of vertical and horizontal shift would be opposite of negative would be a positive 1, and then down 3 is a negative 3. Let's plot this point. There is my new vertex. Now I need to figure out, do I have a compression stretch? I do. I'm multiplying the function by negative 2. If I'm multiplying the function by negative 2, I have to remember that I need to reflect. So I will no longer look like this graph. I'm actually going to be looking like this. I'm going to be reflected about that x-axis. Well, a compression stretch of negative 2 means instead of going up 2 units, I need to go down 2 units from that vertex. And then again, left and right, because the key points for a parabola are to the left and to the right of that vertex. So from the vertex, I have to go down 2 units, left 1. Again, from that vertex, I go down 2 units, right 1. Then, x-intercepts, set the function, negative 2 times x minus 1 squared minus 3 equal to 0. Solve it for x. Negative 2 times x minus 1 squared is equal to 3. Divide both sides by negative 2, and x minus 1 squared is equal to negative 3 halves. Take the square root of both sides to solve, and x minus 1 is equal to plus or minus I square roots of 3 halves. Solving for x is equal to 1 plus or minus I square roots of 3 halves. Now, can I graph an imaginary number? No, so I don't have x-intercepts. Again, finish graphing by making sure you have the same shape. And if you look here, here's my x-axis up here. I'm pointed down. Am I ever going to cross this? No. Makes sense that I don't have x-intercepts. Alright, the next video is going to look at some more examples of graphing by transformations.